Hello and welcome. In this video, we're going to learn discrete random variable. What is random variables? It means numerical random phenomenon. It's usually using numbers to record a random phenomenon, just by literal meaning. And discrete means whole numbers. Continuous means decimals and fractions. So 1, 2, 3, 4, 5, those are discrete numbers. 1.1, 1.3, 1.7, those are continuous numbers because they have decimals. So moving on to discrete random variables, you already know how to read a frequency table. Sorry, this should be read. And here's a frequency table for you. And from this, you can make histograms, stand plots, box plots, and dot plots, and find the mean, median, IQR, standard deviation, and range. So you may be surprised you already know a lot related to stats. So good job. A discrete random variable is essentially the same thing, albeit in a slightly different form. Here is the above data represented as a discrete random variable. So take a look at this. It's still a list, but instead of a list, it's more like a table. And the above row is x, the bottom row is p parentheses x, and p parentheses x represent relative percentage frequency. And this sigma notation represents sum. The sum of all of those frequencies will always add up to 1. We now call the grade on the Chapter 5 test a discrete random variable x. X should always be capital letter, and refer to the probability distribution of x, which lists the possible x values and their probabilities. Note that instead of frequency, the entry below each possible grade is really the relative frequency, which you probably think of as the percent of students in the class who earn a particular grade. Sometimes the distribution of a random variable is provided to you in the stem of the problem. So going back to this, think about for yourself a little bit. How are you going to convert this list to this table? Well, first of all, we recorded each person received different scores. So there's total 32 students in the class. For each scores, those are the amount of people who received them. And what I did is I used 4 over 32, 8 over 32, 9 over 32, and get the each relative frequency. So sometimes you must use probability rules to fill in one or all of the values in the table. Either way, we can do everything with a discrete random variable that we could do with a frequency table, since it is the same information. So moving on to the mean and variance of a discrete random variable. Here is our DRV again. So DRV is just the shorthand for the discrete random variable. Now the mean of x is also called the expected value of x and has a formula using summation notation. So this formula may be looking pretty confused first glance, but let me explain to you. So E of x means the expected value of x. The summation notation is the sum of each value. So starting from 1 to nth value. And what you're going to do is using the x sub I times p sub I. So using each number times its relative frequency. And let us make it in practice. So the formula is really easy to use. You must show your work. So for example, if I want to know mu sub x, in this case, I will use 1 times 0.25 plus 2 times 0.095 plus 3 times 0.28 plus 4 times 0.25 plus 5 times 0.125. And I get the value as 2.905. The variance of x also has a formula using summation notation. So variance just means the the square of standard deviation. So standard deviation square. And how you put it into formula is same thing, using summation notation from the first value to the last value, using the x sub I minus the mu sub x, and all raised to the second power times p sub I. Notice the difference compared to expected value of x. X sub I, instead of using x sub I to times p sub I, we used x sub I minus mu sub x. We want to find the difference between the real value, like the value for each x, minus its corresponding expected value. So again, you must show your work. So if I ask you to find the variance of x, you're going to use 1. Let me show the whole table right here. So you're going to use 1 minus 2. 0.905. So remember that this mu of x, once you calculate it, it will always stay the same. So notice every time I use the 1, 2, 3, 4, 5 minus the same value, 2.905. So you don't have to change for that, but remember to square everything times their relative frequency or relative probability. And then you will get the variance as 836. So if you want to find the standard deviation, you're just going to take the square root of this, and you will get 1.35. Okay, so we will skip this activity for now. Let's take a look at another one. Example is roll 2 dice. If the sum is 2 or 12, you will win $50. If the sum is 11, you will win $30. If the sum is 6 or 8, you will win $10. If the sum is 3, 4, 5, 7, 9, or 10, win $0. Find the expected payout of the game. So what are we going to do is, first of all, list the possible dollars we can win. So from 0, 10, 30 to 50. Each relative frequency has calculated in here. And how are you going to do the expected value is, okay, so let me explain how do you calculate the relative frequency. So for $0, because we have we basically put all of the values in a table right here, and we're trying to find how many possible outcomes there will be, like trying to find the sample space actually. So after we fill out the table, we found out there's 22 out of 36 possibilities to get $0. And to get $10, there's 10 out of 36. To get $30, there is 2 out of 36. For 50, there's 2 out of 36. So if you want to check my work, feel free to do it, or you can just draw a table by yourself and see how your outcome goes. But anyway, we get each relative frequency here, and what we're going to do is using the expected value for x formula to find the expected value for x, which is $7.22. So this is the expected payout. What this value means is, in the long run, if you do this game over and over again, then you will actually win $7.22 at the end. So that's it. And moving on to the transforming a DRV. Let x equal to the number of boxes of cereal purchased by supermarket customers. So most likely the FRQs will give you the questions like this. They will give you a table that is not fully filled out. You're gonna first find out the relative frequency for some of the numbers. So just always remember they always add up to 1. So using 1 minus those possibilities and you will get this possibility. So first of all, finding the expected value for x, you're gonna using the formula and you will get 1.6. For the variance of x, same thing, using the formula, you'll get 0.737. And remember the standard deviation, just taking the square root of variance, you'll get 1.36. If every box of cereal costs $3, a new DRV can represent the amount of money spent on cereal by supermarket customers. So y in this case represent the dollar spent on cereal. So here's our couple options. There's $0, $3, $6, $9, and $12. Remember, they're all like multiple of 3 because each box of cereal only costs 3. So this is the $0 right here represent you buy nothing. For $3, you buy only 1. For $6, you buy 2, and so on. And and just remember that even though the numerical values for y changed, the relative frequency does not change. So each one represent the corresponding frequencies the same, like as x right here. Therefore, we can try to find like some values related to this table, like expected value of y, the variance of y, and the standard deviation of y. And let me show you some very good tips for you to calculate these things. So basically we just times everything by 3 compared to x. So for the expected value, you're just going to times the expected value for x by 3. And that's your new expected value for y. For the variance of y, you're going to times 3 to the square. Because remember that variance is always you have to square every difference and times their relative frequency. So don't forget to times 3 squared, which is 9. And for the standard deviation, we just times 3. It's the same thing as finding the expected value of y. because that makes sense. If you're taking the square root of 3 squared, you'll get 3 back. So here's a little summary for how to use the calculations related to finding the expected value and the variance and standard deviation. So if it's like adding, then if you add something from the original expected value, then for the new expected value, you're just going to add that same numerical value. If you add something to the variance, you don't have to change anything. If you add something for the standard deviation, same thing, you won't change anything. So adding doesn't change spread. Remember, spread just means standard deviation and variance. However, you do need to change the mean or the expected value of the new letter. But this is how you do when you multiply things, is that you're going to change everything. But for mean and standard deviation, you're only going to times that number once a time. But for the variance, you're going to times that number squared. Okay. So skip this for now, and I think that's it for this video. And thank you so much for watching. I hope you learned something from it. So basically, we went through how are you going to calculate mean, variance, and standard deviation, and how does each represent. So thank you so much for watching. Hope you have a great day.